Oh, let's try this one. This is a integral with a square root, and we have a quadratic underneath the radical. So we're going to try a Pythagorean identity. So the two Pythagorean identities we have to choose from are the sine squared plus cosine squared equals 1. And then we can also use the tangent squared plus 1 equals secant squared. But this is the one that, no, I lie. Sine squared and cosine squared could become 1 minus sine squared or 1 minus cosine squared, but we need an x squared minus 3. We need the variable to be the x squared part. So I am going to divide both of these, or this whole thing, by cosine squared to get the other Pythagorean identity that I usually use. So we have tan squared plus 1 equals secant squared, or in other words, tangent squared is the same thing as secant squared minus 1. Now that's better to use for this type of setup in x squared minus 3. So that I can make this a tangent squared, I need this to end up being a 3 secant squared minus 3. In other words, once I saw that 3 there, I'm going to think more along this line. That will help me create a perfect square in here. So if I want this to be secant 3 secant squared minus 3, I'm going to need that x to be exactly root 3 secant. So that when I square it, I'm going to get what you're doing here. I'll get 3 secant squared minus, or 3 secant squared, and then minus 3 would put it in this form, and I could substitute a 3 tangent squared for that. So that sometimes that takes you a while to think about that and get it. So, I mean, you could just pause here and think about that before we move on. But once you're ready, we're basically done. Now you just make your substitutions. This is an x, so we always have to find out what dx equals. Dx would be root 3 times the derivative of secant, which is secant tangent. And now it's all about substitution. So the x squared minus 3, being that x is this, that would be 3 secant squared minus 3, which is 3 tangent squared. Now that's the whole point. We can take the square root of that. Dx, according to this, is root 3 secant theta tangent theta d theta. And on the bottom we have an x, which is root 3 secant theta. So that's our integral. Hopefully we get enough cancellations that everything's going to work out nice. Square root of 3 is a square root of 3. Square root of tangent is tangent. Sorry, square root of tangent squared is tangent. So here's where I am right now. So now I'm going to cancel out anything that can cancel. So it's all multiplication and division. So go ahead and cancel at will here. Perfect. This just comes down to the integral of root 3 is our constant, tangent squared theta d theta. Now that's that would be an easy one if we only knew what the integral of tangent squared was. There's no derivatives that become tangent squared. But there are derivatives that become secant squared. So if we could change this into secant squared, that would be nice. And look up here. Tangent squared is secant squared minus 1. So this is helpful because we know the derivative of tangent is secant squared, so the integral of secant squared is going to be tangent. So this integral, and this is the whole point, you have to somehow integrate this. We've just done it because the integral of secant squared is tangent. Don't forget the 1. The integral of 1 with respect to theta is theta, just like the integral of 1 with respect to x is x. So we've completed the integral. Now we have to substitute. So we're going to use, as we usually do, what we let u equal in this, or in this case, x. So we know x equals root 3 secant theta, which means theta equals x. Secant theta equals x over root 3, which also means cosine theta equals root 3 over x. So if cosine is adjacent over hypotenuse on a right triangle, and I draw a right triangle, adjacent, let me erase that, hold on a second. So adjacent is 3 over hypotenuse on a right triangle. Then I can use Pythagorean theorem to get this side, which would be root, like this squared plus this squared equals x squared. So this would be root x squared minus root 3 squared, which is root x squared minus 3, which you've already noticed we had up here at the beginning of the problem. So that's really kind of like a checkpoint here. You should get that as part of your triangle. It would just work out that way. So now I have this triangle. Now I can substitute theta just by using SOHCAHTOA. So the tangent of theta is opposite over adjacent. Theta is whatever theta is, but look at this. We have secant theta equals x over root 3, or even cosine theta equals root 3 over x. I'll stick with the cosine. It doesn't matter. So theta would be the inverse cosine of root 3 over x. And that is it. I guess I would multiply the root 3 through. But I'll leave it like that. So really cool stuff. I hope you enjoy it.